Hello and welcome to another tutorial. We are looking at the control flow statement, and now we are basically continuing with the for loop or for statement. And we said that in general it takes three statements, right? So the argument of the for loop, the initialization, termination, and then some other statement after that. And we said that the way it works is that initialization happens only once before executing the body of the loop. After that, the termination will be evaluated. Basically, before executing the body of the loop, the termination statement will be evaluated, and then we jump in the body, execute it, and then we come back and execute the third statement. And any of these three statements is basically optional. You can leave them blank, and then but you have to use the semicolon because you have to tell the compiler which statements you're not including. So if you don't include the initialization and don't include the semicolon, it doesn't work because compiler always expects three statements for the argument of the for loop. So when using this version of the for statements, which means the general format, you have to keep in mind that the initialization expression initializes the loop. It initializes the loop. Usually this means that we have a index or some variable that only exists in the body of the loop, right? Like a counter variable or something. And we said that initialization statement can have more than one expression because we know that in Java, when we define variables to initialize them, we can have more than one statement expression, and we separate them with comma. For example, I can say int x equals 0 and then y equals 10, and this is a valid initialization. I defined x before, so x1 and x2, for example. This is a valid initialization statement. It's one statement, but it defines and initializes two variables, right? So this is definitely possible, and you can do the same thing for the initialization statement here in the for loop, right? So you can have define and initialize more than one variable. Typically, we just define one variable. Usually it's I. For example, we say that int I equals 0, etc. When the termination expression evaluates to false, the loop terminates, and the termination expression is evaluated each time before evaluating the body of the for loop. The increment expression is invoked after each iteration through the loop. So you can leave the increment expression blank and put it right at the end of your for loop. It's exactly equivalent. It is perfectly acceptable for this expression to increment or decrement a value, right? And I guess that's the reason they call it increment, but this can be any expression, and it doesn't have to evaluate to any Boolean value. The only expression here that has to evaluate to Boolean value is the termination. The following program for demo uses the general form of the for statements to print the numbers 1 through 10 to a standard output. So we have this for loop. As you can see, the initialization statement just declares or defines an integer value I. It starts with the value of 1, and then the termination condition is that I less than 11. And then the third expression that is evaluated after the body is basically evaluated is the third one, which is I++. And we can use ++I. These more or less the same in this context because we're not using the return value of the I++. Now we could use the return value of the I++, but in this case we're just using the I++, and we're not using the return value of this operator ++. So how does this work? When the runtime hits the for loop, this line of code, it first evaluates this initialization statement only once, and it creates an integer value called I with a value of 1. And this is assumed to be the local variable confined to the body of the for loop, which means after we hit the last curly braces and we jump out of the for loop, this I does not exist, right? Now we can in fact declare this I variable outside the for loop before the for loop, initialize it with once, then the I actually exists after we jump out of the for loop. But this is the best practice, and I highly recommend you always try to follow this practice of declaring the counters or indices, or whatever you need that only works in the body of the for loop, always define them as a local variable. As I mentioned, you can define and declare more than one variable here. Obviously, the downside here is that you cannot declare two different variables with different types. We know that if we want to define two integers and initialize them, we can do it in one statement. We just separate them with comma. But we cannot do the same with two separate variables like int and double. You cannot do it in one statement. You have to define the int first, semicolon, and then the double. And because initialization has to be only one statement, it cannot be two statements. You're not allowed to basically define and initialize variables of different types in this argument of the for loop. But you can always define and initialize multiple integers at the same time. All right, so this gets evaluated only once, a local variable I created, and then before executing the body of the for, we first check the condition, the termination condition, I less than 11, that's true. After that, we don't execute the third statement. Instead, we jump into the body of the for and execute that. And after this is executed, we jump up and then evaluate the third expression before checking the termination condition. After the third expression is evaluated, we jump back to the termination condition and see if it's true or false. If it's true, we execute the body again, we jump back and check the third expression, and then jump back and check the termination statement, and this continues until when we either somehow break out of the for loop or the termination condition returns false, right? Obviously the output is 1 to 10. Let me create a for loop here, for loop class to demo this concept. So I'm going to create a method here, public static void test1. And then in the main, I'm going to execute test1. And in the test1, I'm going to exactly copy and paste this. All right. And then if I execute this, as you can see, it works fine. So this is a standard way of dealing with it. So a standard way for looping using a for loop, right? And again, the best practice is to always define your index, loop index or loop counter. So here the I variable is in general, it's called the loop counter, right? And the termination condition is based on a condition that we put on the loop counter, and then we increment it. Yes. So this is one. The next one is in test2. What we do, as I mentioned, we don't need to put this statement I++ here, right? We can leave the third statement blank and then just say I++ at the end of the body. These two are exactly equivalent because the for loop eventually translates into, after the termination condition is evaluated, the body is executed, and then we jump back and evaluate the third, and then we jump back and evaluate the termination. Same here, the body is executed, we increment I, the same as here, and then we jump back up. Because there is no third statement, we just directly jump back to evaluating the termination condition. Note that if I remove the semicolon, I'm going to get a compilation error, right? Because the compiler always expects you to have three expressions, even empty expressions, but actually three statements, even empty statements for the for loop, right? For the argument of the for loop. All right, so this is let's call this variant 1, which we put the increment here. Now, so if I do for example, sysout here, let's separate this and then go ahead and execute test2. Obviously, we expect to get the same result from 1 to 10, from 1 to 10. All right. Now, what's another variant of this for loop? Let's call this test3. We don't need to define this counter, right? Obviously, the best practice is confine the value, define this as a local variable, which means we define and initialize it in the for loop argument. And then this I doesn't exist. So if I say I++ after the for loop, I get a compilation error. And the compiler tells me that I cannot be resolved to a variable, which means you never declared it or it doesn't exist. That's because as soon as you hit the closing curly bracket of the for loop, this I no longer exists. It's destroyed, right? And in the variant 2, we're going to define and declare and initialize this outside the loop. This is still perfectly valid. The upside is that now this I variable is available after we jump out of the for loop. Most likely we don't want that. That's why this var2 is not recommended, because maybe we want to define another for loop after that. And so basically, if I define another for loop after that with the same I variable, then I'm in trouble, because here I then has a value of 11 when I encounter this loop. Whereas in this case, if I copy and paste this is perfectly valid, and each loop still goes from 1 to 10, right? The I for this for loop doesn't interfere with the I in this for loop, because there is no memory. As soon as we hit the closing, we jump out of the for loop, this I no longer exists, right? So be careful when you try to use a loop counter which has been defined and initialized outside the for loop. Be careful about that. This can, if you just do this and do copy and paste of the for loop and don't forget to change the index, then you might run into troubles, right? So be careful about that. So in var2, we put the increment statement or the third expression actually in the body. At the end of the body of the for loop, we can define our loop counter outside the loop and initialize it. And if I run test3, I get the same result. Yes, as you can see, all of these three cases print 1 to 10. Now, the final statement is we can even left the for loop to run forever, like this, right? If I do this, then obviously this for loop, this is perfectly valid. I want you to understand this. This is a perfectly valid code, and this is equivalent to while loop when we say while true, right? And then we have a body. This is infinite loop. So for without any restriction on the expressions, it's an infinite loop. It goes forever, exactly like while true, right? You don't even need to put true here for the condition, because this just it just jumps here. It sees that there is empty expression, which means there is nothing to evaluate, which means just continue executing the loop. So if I run test4, this has to go forever. Test4. And as you can see, it's an infinite loop, right? It never terminates. Don't think that you have to set true for the condition so that it goes forever. You don't have to do that. When in the for loop, when one of the statements is not present, it's empty, it means just ignore it and continue the rest of the loop, right? So this is the notation of an infinite loop. We have perfectly empty things, right? And so let me write it. This is an infinite loop, right? Exactly like while true do something, right? And then if we want, we can manually break out of the loop, by saying that if I equals 11, then we're going to say break. And what this does, this breaks out of the innermost loop, which is this for loop. So if I run test4, I should still get 1 to 10 in all 4 cases, right? So here we are manually taking control of how the flow of the thing happens. We just create an artificial for loop that runs forever, and we can jump out of the for loop under different conditions. Now the upside here is that we can have for example, jump out of the for loop under different conditions. Remember, if you put a condition here, I less than 20, for example, you cannot have multiple conditions, right? I greater than 10. This doesn't work. You can only have one condition. If you want to break out of the loop under various circumstances, you have to manually control the flow of the for loop using break statements and if, right? Conditions and break. This way we take a manual control of the loop. All right, let's continue. Notice how the code declares a variable within the initialization expression, and we said that this means that this variable I is confined to the scope of the for loop. The scope of this variable extends from its declaration to the end of the block, governed by the for statements, so it can be used in the termination and increment expression as well. If the variable that controls a for statement is not needed outside the loop, it is best to declare the variable in the initialization expression. As I mentioned, this is the best practice. The names I, J, K are often used to control for loops, for the loop counter, right? Declaring them within the initialization expression limits their lifespan and reduces errors. The three expressions of the for loop are optional. As I mentioned, an infinite loop can be created as follows. So if you say for empty initialization, empty condition, empty the third expression, you end up with an infinite loop. The for statement also has another form designed for iteration through collections and arrays, and it's called a for each or advanced for loop. This form is sometimes referred to as the enhanced for loop or enhanced for statements, or sometimes for each statement, and can be used to make your loops more compact and easy to read. Basically, the idea is that if you don't care about the index and you just want to iterate through all the elements, remember the keyword here is that all the elements of an array, a collection or something, then you don't need to write a for loop based on the index or a counter. You can use the for enhanced for loop or a for each loop. And I'm going to show you here. So let's copy and paste here. Let's call it test 5. Now in test 5, what I'm going to do is we're going to create an array, and we've seen this in the previous lectures, how to define and immediately initialize an array, right? So you don't need to say new int like this syntax. You don't need to do this, right? But if you use var on the left hand side, then yes, you have to use this new int. But then if you use the int array type on the left hand side, you don't need to use this, and the compiler understands the type are ints. Obviously, if you, as I mentioned before, if you mix the types, then the compiler gives a compilation error, and the compiler automatically deduces the number of elements, right? All right, and then for loop for iterating over an array. So for int I equals 0, I less than the name of the arrays dot length. Remember, length is the integer final field, and then let's say plus plus I or I plus plus, and then sys out numbers at index I. This is index based iteration. So index based iteration, and remember, my goal is to iterate through all the elements. Remember, the keyword here is that we want to iterate through all the elements, of the array. Now with the index based for loop, obviously I can change this condition. So I can say this -3 all the way from beginning to the fourth index from the end, right? So let's comment this out. Test 5. If I run this, I go from 1 to 7 instead of 1 to 10. If I basically remove this, 1 to 10, right? So this has more flexibility, of course, because you can play with the condition. You have the flexibility. And one thing that I like to mention, as I mentioned, one thing that I typically personally do, I cache this length value, because remember, at runtime, the compiler has to, I guess, in each iteration, after we execute the body, we have to come back and evaluate this. And in order to evaluate this, the runtime has to jump into this numbers array and read the field, right? But if we cache it in the initialization, then so we can say len equals numbers.length I less than len. So I recommend that you try to always do this. This has a little bit of advantage or performance improvement, because initialization happens once, because lengths are also of type integer. So we initialize the loop counter, initialize the length, and then when we go ahead and evaluate this I less than len, we don't need to figure out what the length value is, right? Because we don't need to jump into the numbers and read the length field. It's already there, cached as a local variable. So it's a little bit of performance improvement, and I recommend you to do this when you try to iterate over arrays, right? Now the enhanced for loop is like this. The way we do it, we say that for int some value x or number colon, which means in numbers array. This is the syntax, and then when this number becomes a local variable, again confined to the body of the for loop. But this number is not a counter; it's the actual element inside this array, right? So this colon means in. So this character colon in this context means inside or in the array, right? And then we can print the number this way. So this is called enhanced for loop, or sometimes we call it for each loop. That's because we're saying that for each means it implies all the elements. For each means for everything. We don't want to restrict to just a particular range of elements, right? So you don't get to decide how many elements to iterate through. It goes through all the elements, right? So if I run this, it's going to also print me 1 to 10, right? Now, behind the scenes, in the next lecture, we will look at the difference in the bytecode for these two. And you will see that behind the scenes, something else happens in this for each loop, right? Now, Eclipse has a for each template for this kind of for loops. This is the last thing for this lecture. So in the Eclipse, if I type for each, you see this template pops up, iterate over an array or iterable, and it automatically recognizes these numbers is probably here, I is then, and then I can say sysout I. So Eclipse has a template for the for each loop, because usually we work with collections, arrays, and we just want to print them to the console or write them to a file or something. So most of the time we want to iterate through all the elements of the collection we're working with. So this enhanced for loop is a nice thing to have. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.